Okay, reactions of acids and bases. We've talked about reactions of acids and bases, so a lot of this should be review. We learned earlier that acid-base reactions generally form water and a salt. And by salt, we don't mean specifically sodium chloride, we mean an ionic substance. So here we have an example, HCl plus KOH forming H2O and KCl. Here's the acid, this is the base. Here we have water, and we have the salt. And if we do a complete ionic equation and then figure out the net ionic equation, we come up with H plus OH minus, giving us water. That is the net ionic equation for many neutralization reactions. Now, when an acid reacts with a carbonate, like sodium carbonate or calcium carbonate, or with a bicarbonate, a hydrogen carbonate, the products end up being carbonic acid and salt. And the carbonic acid that's one of those gas evolution reactions we talked about. It's unstable and it decomposes and forms water and carbon dioxide in the gas form. So here we have HCl and baking soda, sodium hydrogen carbonate. And they're going to form kind of as an intermediate. You're going to get H2CO3 plus sodium chloride. But H2CO3 isn't stable, it decomposes into H2O and CO2. So this is an example of a neutralization reaction which would not have that common net ionic equation, because it's also gas evolution. So we should be able to write equations for neutralization reaction. This is asking us to write a molecular equation for the reaction occurring between aqueous H3PO4 and aqueous NaOH. Well, let's write down our reactants, H3PO4, and it says it's aqueous, and NaOH. Now, this hint says H3PO4 is a triprotic acid. When we look at this formula, H3, all three of the hydrogens here are written at the beginning. That means it can release 3 protons. This is like a mom with triplets, okay? She could give you 1 to babysit, she could give you 2 to babysit, or she could give you all 3 of them. A triprotic acid. Because it has 3 protons it can donate. When you have a triprotic acid or a diprotic acid, you need to be careful when you're balancing the equation and make sure you pay attention. Triprotic acid is going to take 3 moles of hydroxide. 1 mole of hydroxide for each mole of hydrogen ion. Well, what are the products here? Acid and a base, so we're probably going to end up with water and salt. But you can also go back to the idea of taking these two, separating them into the ions, and swapping partners. So the ions present in this compound are hydrogen ions and phosphate ions. And in sodium hydroxide, we have sodium ions and hydroxide ions. And if we swap partners, we're going to get H plus with OH minus. That's going to give us water. What's the state of water at room temperature? It's a liquid. We don't want to say it's aqueous because that would be kind of silly. Water is dissolved in itself. The other product is going to be sodium ion and phosphate ion. You need the charges, the correct charges on these two so that you can get the formula correct. There's a -3 charge here and a +1 charge. So that tells us we need 3 sodium ions to balance the charge on the phosphate. The formula is going to be Na3PO4. How would you predict the state of that? You'd need to use the solubility rules. Sodium compounds are always soluble. So this is aqueous. So then we've got our products, now we need to balance it. So here we've got 3 H's. That's a big clue that we're going to end up with 3 water molecules. We're going to need 3 water molecules. Sodium, there's 3 sodiums, so we're going to need 3 sodium hydroxides. There's 1 phosphate over here, and we've got 1 phosphate over here. Let's make sure that this 3 is working for us. 3 oxygens. Well, there's 3 oxygens from here. Those 4 oxygens are over here. And then we've got 3 times 2, 6 hydrogens on this side. We've got 3 hydrogens here and 3 hydrogens there. Any questions? So acids undergo neutralization reactions with bases. They also dissolve many metals. I can't remember if it was magnesium or zinc that we made the hydrogen gas with, but they'll both do it. If you put magnesium in hydrochloric acid, it undergoes a single replacement reaction and forms hydrogen gas and salt, a soluble ionic compound. Zinc will react with sulfuric acid and produce hydrogen gas and salt. Iron reacts with acid, forming hydrogen gas and salt. So many metals will react with an acid to form hydrogen gas and an ionic compound. But there are some metals that do not react with acids. Here's a picture of what happens when you do magnesium in HCl. You see all the bubbling? That's the hydrogen gas. Acids can also react with metal oxides. So here's a metal oxide, K2O, reacting with acid. And what happens there is you get water and a salt. So in a way, that metal oxide is acting like a base, but it's not a hydroxide. Acid reacting with a metal oxide to form water and salt. So we've got basically we have generally 2 possibilities. We could get water and salt, or we could get hydrogen gas and salt. So write the equation for each reaction. HCl reacting with strontium metal. Well, hydrochloric acid, HCl, and strontium is Sr. So in summarizing these reactions, I said, well, the possibilities are we could get water and salt or hydrogen gas and salt. Could we get water out of this one? No, there's no oxygen in the reactants. That's completely impossible. So it must be hydrogen gas and a salt. So we're going to get hydrogen gas. Hydrogen is a diatomic element, so it has to be H2. And then what do we have left here? We have chlorine and strontium. What kind of an ion does strontium make? It's on the periodic table. Positive 2. So that's going to become a +2 ion. It is not a +2 ion here, but it's going to become one. I should really just write these over here. That's kind of confusing to have them there. So we've got strontium, which we know from the periodic table makes a +2 ion, and we have chlorine, which we know from the periodic table makes a -1 ion. So in putting those together, we get SrCl2, and we need to balance the equation. Well, the strontium's fine, but the hydrogen and the chlorine are a little out of whack. If we put a 2 over here, we'll get it balanced. Any questions? Reaction of hydroiodic acid with barium oxide. Hydroiodic. The prefix hydro tells me it's not an oxyacid. So this is HI. and barium oxide. Okay, so that's barium with oxide. Oxide is 2- from the periodic table. And we look at barium on the periodic table and find out barium is 2+. So we have high plus BAO. BAO. Well, we could make hydrogen in a salt, or we could make water in a salt. Water in a salt. Here we've got oxygen, so we could make water. So make water, H2O. And then what's our possibility for the salt? Well, the hydrogens and the oxygens are all going to go into the water. And then we're going to have barium. And the other ion there is iodide. And we look at the charges, and those charges will tell us what the formula for the compound is, which is BaI2. And then we need to balance it. Well, we've got one barium and one barium. We've got one oxygen and one oxygen. Over here we have 2 iodines, so we better put a 2 over here. And that gives us 2 hydrogens and 2 hydrogens. Any questions? If you can make water, do it. Water and a salt. If not, hydrogen and salt. What about bases? Well, the most important base reactions are the neutralization reactions. Those occur with acids. We already talked about those. The only other one we're going to talk about is sodium hydroxide with aluminum. We actually did this. Do you remember when we took the foil and we dissolved it? We dissolved it in potassium hydroxide, but it will dissolve in a base. Aluminum is one of the few metals that will dissolve in base. Most will not. So sodium hydroxide plus aluminum, and there has to be water present, gets us this funky looking thing. Okay, we did not learn how to name things or predict things like this. I'm just saying, look, this does this. There it is. Sodium, aluminum, tetrahydroxide. We're not going to name that. Anyway, there it is. It happens. You don't have to memorize that.